Ever since I acquired my first CPM systems, the K-Pro 2 and the Osborne 1, later then as well building an Altair 8800 replica, I wondered if and how those could be networked. Not an obvious thing, as neither the K-Pro 2 nor the Osborne 1 offer an S100 bus, and neither does the Altair 8800 replica, at least not the one that I have, so potential S100 expansion boards are out of question. But then I found out that Digital Research's network operating systems CPNet and NPM actually just use the serial interfaces. Let's talk about legacy network technology. I'm the Vintage Collector and these are my stories. So I started to familiarize myself with CPNet and NPM using the C80Pack simulator. So you heard it, no hardware shenanigans today. And this was a wise decision, as getting into CPNet and NPM wasn't as straightforward as one would expect. So I went with Udo Munk's C80Pack that I cloned from GitHub. Nothing easier than running make, but what's that? Errors on the OpenGL dependencies. And there's no /user/x11/include directory. Of course not, as macOS doesn't include x11 since many years. At this point I made an unnecessary detour, as I was distracted for one by the straightforward procedure outlined here. Although it clearly applies to a Debian-like system, it shouldn't be that different when running on macOS, right? I mean, I have Xcode, and this as well brings OpenGL along. After some googling, I started changing the source code to repoint to the framework libraries, which even made some errors during the compile disappear. But look, here's another one, a missing reference to glx.h. Wait a second, glx is the OpenGL extension for the X Windows system, which is not part of macOS since 2012. So I went straight to installing Xquartz and then actually reverting my code changes, and voila, C80Pack compiled like a charm now.
And now tell them about the documentation.
Right, had I actually been looking into the doc folder inside the repository, I would have seen the macOS related readme right away that would have told me that in the first place. So I did it the hard way. Anyway, once compiled, I was looking through C80Pack's directories. The simulator brings a lot more than just a CPM simulator. Actually, it includes, amongst others, a simulation for the Altair 8800 and the Chromemco C1. As such, it also includes the graphics panels for those machines, the reason why there was some OpenGL dependencies. But I won't be looking into this today, but focus on cpmsim, which is a command line only CPM simulator. Inside the cpmsim directory, you'll find the compiled cpmsim binary, as well as a handful of startup scripts and the directory containing disk images. C80Pack bundles a few CPM disk images already, though not the ones for CPNet and NPM. Those can be downloaded directly from Udo Munk's website. At first I had extracted them to some different directory until I realized those are meant to be directly extracted into the cpmsim directory structure. So while I'm moving around my files, you'll see the correct procedure outlined in the annotations. I then tried starting my first CPNet client, though I somewhat had the impression something was wrong, for example, receiving bad sectors when trying to access drive B. Also, I had the impression my boot drive wasn't containing the expected disk image. After some investigation, I found that these startup scripts coming from cpnet and npm actually link the boot images into the disk's directory with a cpm extension. But those are obviously not loaded by cpmsim, which according to its source code only looks for .dsk file extensions. So I changed the boot scripts to read drive a.dsk and drive b.dsk accordingly, after which I ended up with the correct disk images loaded. I then found that the conf directory includes two example files, one being the net_client.conf and one being the net_server.conf. Apparently, the documentation of c80pack is incomplete on this behalf, but the way I understood it from reading the source code, what it does is the following. Let's take the perspective of a server which will process net_server.conf, which in turn would take any given console port, or in our context rather serial ports, and open a listening TCP socket for it. If the telnet flag is set, it would allow for incoming telnet connections so as in to pass them into an actual console. Mind this, as I will be coming back to this again in a moment. For a client, net_client.conf is processed, and any console port given is connected to the given TCP socket. Simplified saying, this plugs a virtual cable between the two simulated serial ports, one on the client side and one on the server side. At the example of the npm simulation, you get to see this here when it reports the 4 ingress listening sockets. Now, what intrigued me is the fact that the configuration file handling is not well documented and furtherly not controllable via command line arguments. That said, looking at the code again, it looks like those config files are always processed given they exist. There's nothing generally wrong with this approach, but it didn't particularly fit for my purpose. But I started hacking up my own startup script with a single goal in mind. It should start one npm server simulation listening on 4 TCP sockets, mapping them to the 4 serial lines. It should also start 4 cpnet client simulations, each connecting to one different of the 4 server TCP sockets. And let me remind you, even though cpmsim uses TCP sockets for making the serial console ports available for connecting them between the simulations, this all stays purely on your host running the simulation. For the cpm and npm guest operating systems, this is totally agnostic and they know only about serial ports and not about TCP/IP. So eventually I had my script all hacked up to start one server and 4 clients. I used tmux to start all simulations into concurrent sessions through which you can page through from within tmux. Now, on Udo Munk's website there's multiple versions of cpnet and npm available. I tried with release 1.1. While npm did start once entering the npm ldr command, the client, for whatever reason, seemed to always lock up after running cpnet ldr. So I then tried with release 1.2, which fared much better. Again, starting up npm on the server using the npm ldr command will do, which will also change the prompt. You can get some basic system status information by running the npm stat command. On the client, run the cpnet ldr command to load cpnet on top of cpm. Then run the login command. In its default configuration, there's no questions asked, so it'll be just on the network. I was then trying to fiddle around with the network command, though no quick command line help exists, as usual for the time. You can map drives, and it follows the same syntax of the pip command, with the local drive specification on the left hand side and the remote drive on the right hand side. The cpnet sts command will provide some status information if you so desire. And voila, we're now browsing drive B on the npm server, which was mapped to drive C on our cpnet client. So indeed, via simulated serial connection, npm is acting as a file server. I was then trying to make any sense of the mail command that comes with npm. There's both broadcast mode as well as a mode to send directed messages to a given destination ID. But wait, how would that work even with logon before not asking for passwords, IDs and anything? Well, obviously not, and I'll have to investigate deeper into this and also trying to figure out what this means. Server mail drive not networked. At least I found a mention in the documentation that mail only works if the temporary drive is shared, and that message means exactly that. But which one is the temporary files drive and where and how to configure it? Keep that one in mind for later. One further thing I noticed at this stage was that my clients number 1 and 2 were never able to log into the server over the network. Do you remember the telnet flag seen earlier in the net_server.conf file? As I had disabled it when trying from the macOS host, I would clearly not get the remote console to npm. However, when explicitly enabling the telnet flag and reloading the npm server simulation, I was able to perform a remote logging to npm. That said, it was obvious as long as the npm was using the first 2 serial ports as a remote console, they would of course not be available for network connections. After reading through the npm system developer's manual, I found that regenerating the kernel by means of the gensys utility should achieve the desired effect. It asks for TMPs, terminal message processors, or in other words, system consoles. Setting it to 1 should just enable the default console but disable all others. I also disable printers as I don't have any. And remember what I said earlier on about the temporary files drive? This is where it is set, by running gensys. Then, after reloading, I was totally surprised seeing the remote consoles for the serial 1 and 2 lines still working. Also, npm stat still reported that obviously there was 1 printer and 2 TMPs enabled, which is also reported up here. Well, it turned out that I was expecting some kind of automatic behavior when there was not. Obviously, the new npm.sys file was generated on drive B but never transferred to drive A, hence I was always booting the original kernel. So I copied it over manually using the pip command, which on the next reload finally reported only 1 system console. Okay, that should do it for the client number 1, or does it? Apparently, I'd still end up in my client simulation stalling when connecting to the first TCP socket on port 4001, which represents the first virtual serial port. And although the cpnet manual says the server process is good to serve up to 16 requesters, in theory even 256, I thought I may need to adapt the network if.asm file. For that to go a bit more comfortable, I installed the cpm tools via the brew install cpm tools command. This then allowed me to extract the network if.asm file from the second npm disk image, so I could change the number of slaves by changing the NMB slaves from 2 to 4. I also ran quickly through the code and found multiple references to NMB slaves, so it seemed reasonable to me to increase it. And by the way, in case you wonder where the default password is defined, this is here. Then I uploaded the changed file back to the npm disk image and assembled it, then running gensys again to rebuild the kernel. And don't forget to include the server.rsp and networkif.rsp as resident modules, as otherwise there won't be a network functionality available. After I had copied the newly created npm.sys file to the boot drive and reloading npm, I see 4 running queues for the network interfaces and of course only one TMP active. So that should do it in my opinion, but apparently not. The simulations connecting to the consoles on TCP ports 4001 and 4002 would still lock up and log in, whereas only the ones connecting to ports 4003 and 4004 would work. Either my understanding of the required modifications was wrong, or the alterations done to networkif.asm by Udo Munk changed the way it's working. I have a very concrete suspicion, but when trying to check on Udo Munk's repository, I found he didn't check in the original source but just the altered code. So I went to check against an original code listing that came from the CPNet reference manual, and my suspicion turned out right. I was so guessing that the network server was not listening to the first and second serial ports at all, and when looking at and comparing the two code versions, you see that Udo Munk's version points to the network interface on network IP0 and network IP1 to the same target, like network IP2 and network IP3, namely 200 and 300 hex. Where in fact the original code by Digital Research points them to 0 hex to 300 hex respectively. So I changed the code to reflect the proper values for the first two network interface processes. Then I recompiled everything again, and finally all 4 of my simulated CPNet machines would be able to connect to the npm server. And remember my earlier issues with mail. Turns out all what's needed is to map said temporary files drive, which is A from the npm server's perspective, to let's say drive C. That's what I did. Then when sending a message, add the requester ID as a recipient. You'll get that from the cpnet sts command, which in my example is 11 hex. This will create a message file called 11mail.tex on the C drive. Now when opening it up from another station and hitting the receive mail key, I will get to see said message. Now, as you see here, all my simulator machines currently have the same requester ID. So apparently this doesn't make sense, as the ID should obviously be unique in the network. Now, the requester ID can't be passed via the login command, so it's likely to be hard-coded somewhere as well. And this somewhere is actually on the CPM client disk within the SNIOS.asm file, where you will find this reference to the requester ID being 11 hex, although it's defined as slave ID. Now, instead of copying it out to my macOS host for a more comfortable editing experience,
I doubt VI is counting as comfortable.
let's do it inside CPM using the archaic add-line editor. Luckily, the CPNet disk found on Udo Munk's website already includes the SNIOS.asm file, so it's easy to edit the line accordingly to use 12 hex as a requester ID. To recompile, you can use the sysgen.sub submit file, which will carry out the necessary steps. After reloading CPNet, the cpnet sts command will now show a different requester ID. Said that, I can now send the message to requester 12, which will again get its own temporary file named 12mail.tex on the C drive. And when running mail from station number 2, it will in fact receive just that email, which I can as well delete once I've read it. And now that I have figured out how the things work with the temporary files drive, also the broadcast function does what it should. This is stored to the 00mail.tex file, which is in turn read by the mail program, so I get to read my own broadcast message as well. Now, there's more to explore, like how to patch CPM's CPC to auto-start CPNet and NPM respectively, or if it makes any difference when running on real hardware like the Osborne 1 or the K-Pro 2. Plus, I didn't really look into the barely existing security features, especially for securing the login process. And yet, there's also that project here, which implements a CPNet server running directly from Unix. So I'm just at the beginning and not at the end of my CPNet journey. So what do you think about CPM's network capabilities? Let me know in the comments below, and if you feel like supporting TPC, then please check out the various options for channel memberships or gear donation right here. I'm the Vintage Collector, and this was my story for today. Thanks for watching, and see you again next Sunday.